Welcome to The Explainer. Today, we're pulling back the curtain on something that runs pretty much our entire digital world, but most of us never see it: the database. It is the hidden, invisible architecture that powers almost everything you do online.
I mean, have you ever stopped to think about that? How your shopping cart just stays there? Or how you can pull up a photo from 5 years ago in seconds? Well, the answer to all of that is the database. It's the engine humming quietly in the background of your apps, and today we're going to pop the hood and see exactly how it works.
All right, here's our game plan. We're going to tackle this in 5 straightforward parts. We'll start with what a database even is. Then we'll look at the system that runs it. After that, the 2 main types you'll encounter. Then the language we use to talk to them. And finally, we'll see that language in action. Ready? Let's get into it.
So, first things first. What exactly is a database? Well, the easiest way to wrap your head around it is to picture a giant, perfectly organized, digital filing cabinet.
I mean, think about it. Its whole job is to prevent data chaos. Imagine trying to run an online store with customer info just thrown into random text files. It'd be a nightmare. A database brings order to that chaos. It makes all that information structured, searchable, and manageable.
Okay, so if the database is our giant digital filing cabinet, you've got to wonder, who's the one keeping it all so perfectly organized? Well, that brings us to our next piece of the puzzle, the database management system.
This is where the DBMS, or Database Management System, comes into play. You can think of it as the super smart, always-on-duty librarian for your data. It's the software that stands between you and the raw data, making sure everything is handled correctly.
And this librarian does a ton of work behind the scenes. It's not just storing the files. It's managing how you add new ones or change and delete old ones. It's in charge of finding the exact piece of information you ask for. It even makes sure the data stays accurate and isn't corrupted. And maybe most importantly, it's the security guard, controlling exactly who gets to see what.
Now, this is where things get really interesting, because not all databases are created equal. You basically have 2 main philosophies, or flavors, when it comes to storing data, and choosing between them is a huge deal.
On one side, you've got relational databases. Think of a perfectly organized spreadsheet, but on steroids. Everything is in neat tables with rows and columns. The rules are strict, which is fantastic for making sure your data is clean and consistent. On the other side, you've got NoSQL. This is all about flexibility and speed. It can handle massive amounts of messy, unstructured data, like social media posts or sensor data, and it's built for lightning-fast performance. So it really boils down to this: do you need strict structure, or do you need massive scale and flexibility?
Okay, so we have these powerful systems, but how do we actually communicate with them? Especially the relational kind, which are so common. You can't just type a question in plain English, right? You need a special language.
And that language is SQL, which stands for Structured Query Language. It's the universal standard. Now, the magic of SQL is that it's declarative. All that means is you simply tell the database what result you want. Like, hey, show me every customer who lives in New York. You don't have to give it the step-by-step instructions on how to go find it. The DBMS is smart enough to figure that part out for you.
Now, while SQL is the standard, it's kind of like a spoken language. Different systems have their own local dialects. The basic grammar is the same, but some of the words change. For example, to get the top 10 results, Microsoft's system uses the command top 10, but MySQL uses limit 10. Same goal, slightly different way of saying it. It just shows you how diverse the landscape is, from huge corporate systems like Oracle to tiny ones like SQLite that might be running on your phone right now.
All right, enough theory. Let's get our hands dirty and see what this stuff actually looks like. We're going to watch how just a few lines of code can take an empty shell and turn it into a database with real, useful information inside.
Real quick, SQL commands fall into a few main groups. The 2 big ones you need to know are DDL and DML. DDL, the data definition language, is for building the skeleton, creating the tables. Then there's DML, the data manipulation language, which is what you use 50% of the time. That's for working with the actual data, adding it, changing it, and fetching it.
So check this out. Here's a perfect, simple workflow. Step 1. You use a DDL command, create table, to build the empty container for your user data. Step 2. You use a DML command, insert, to actually put a person's information into that container.
And finally, step 3, you use the most famous command of all, select, to ask the database to give you back the specific data you're looking for. See? It's a logical flow. Structure, then data, then retrieval. And you can get incredibly efficient. Look at this. A single insert command loading 10 complete user records into our table, all in one shot. Now, what's really wild about this is that this entire block of perfect SQL code was actually generated by an AI, which just shows you how these new tools are changing how we work with data.
And that leads us to a pretty mind-bending final thought. We just saw a machine write flawless code to talk to another machine. So, as AI gets better and better at speaking the language of data, what does that mean for us? What's the next critical language that we're going to need to learn to keep building the future?